Subscribe to my channel and press the bell icon. Hello everyone, welcome to my channel on Learning Field. Today we will derive the relation of electric field and potential. So let us derive the relation between electric field and potential. Since we know the expression of electric field and potential, isn't it? We write electric field is equals to kq by r square, isn't it? This is the relation you have learned about the electric field lines in the chapter 1, isn't it? This is the relation for electric field lines, and we have also learned the relation for the equation for potential, isn't it? Potential V is equals to kq by r, isn't it? We have learned in the previous chapter, and chapter 2 also we have learned the relation between now we are going to derive about the relation between electric field and potential. Since we know the derivation of this electric field and potential, now we are finding the relation between E and V. So to find the relation, first of all we need to differentiate this one. Differentiating V with respect to R, that represents the gradient of V. So we need to differentiate this equation number 1, dV by dr, which is equals to ddr of kq by r. Okay, just we need to differentiate. Now we can write dV by dr, which is equals to, now if you differentiate this one, this constant will come out, and what will remain here? This constant will come out. Suppose kq ddr of 1 by r, only 1 by r will remain here, and kq will come out since it is constant. So dV by dr will be equals to kq. Now this 1 by r can be written as r to the power minus 1, isn't it? We have learned already this one. We can write this one 1 by r as r to the power minus 1, which is equals to dV by dr, which is equals to, now if you see here, you need to write here r to the power minus 1, you need to write here ddr of, so kq by ddr of r to the power minus 1. Now I'll tell you one formula regarding this. So ddr of r to the power minus, suppose this is n, r to the power n, which is equals to, this is the formula, okay, will be equals to n r n minus 1. Just we need to substitute in this formula. This is the formula of differentiation. You need to remember this one. This formula also is there in maths class 12. So by substituting the formula, since we know that n means what? N means minus 1. So minus 1 into, here r means r, isn't it? So r. Now n minus 1. What is n here? N means minus 1. So minus 1, and from formula minus 1. So dV by dr will be equals to kq. Now if you see here, this minus will multiply into kq, so minus will come out, and r to the power minus 1 into minus 1 will be equals to r to the power minus 1, so into r to the power minus 2. So dV by dr, which is equals to, now you see here, this r to the power minus 2 we can write r by 2, isn't it? Or sorry, we can write this one as r to the power minus 2, we can write as 1 by r, isn't it? So minus kq, we can write r to the power minus 2 as r square. Okay, so this is the required relation we need to prove. So but we know that, since we know that electric field equals to kq by r square, but electric field is equals to kq by r square. So if you compare these two, directly we can write like this. This kq and kq cancel, only minus sign remains here. So we can write like electric field which is equals to minus of dv by dr by comparing this equation, comparing 1 and suppose this is 2, comparing 1 and 2, we can write this one as electric field is equals to minus kq by, that means electric field is equals to minus dv by dr. This is the required relation. Don't forget to subscribe and share my channel. Thank you.